Hello and welcome to another Java tutorial. In this tutorial, I'm going to continue our discussion on Java native interface and talk about a very important topic, which is how to use C++ classes and structs in Java. So far, we've seen the other way, right? We've seen how to use Java classes in C++, how to call them, how to call methods of Java classes in C++. Now we want to see how to use C++ classes and structs in Java. Let's say I have a library that has some C++ classes and I want to directly get access to them and use them. So working with C++ classes and structs in Java. And if you're not familiar with the difference between structs and classes, is that they're essentially the same thing. I think C++ kept structs so that it's backward compatible with C. The main difference is that all the members of structs are public by default, and all the members of a class in C++ are private by default, right? So this is the two difference. So if you inherit from the struct, by default it's a public inheritance. If you inherit from class in C++, by default it's a private inheritance. But obviously we have modifiers. For example, you can inherit from a class in C++ as a public inheritance, or protected, or private, right? So working with C++ classes and structs in Java, JNI does not provide an easy way to map Java objects to C++ objects and vice versa. So if I have a C++ class, I cannot just so JNI doesn't provide any easy way to have a Java class that maps directly to that C++ class. So, and the reason is that JNI, again, it's a FFI layer, or it's a foreign function interface, which means it can only call functions, foreign functions, which means native functions, native C++ functions. So JNI can only call functions in C++, not classes. For example, it cannot create a class and send back to Java a class, right? So it can only call a C++ function and send the results back to Java. And obviously, if the result is a C++ class, it's not going to work. So we have to do something else. So how can we directly work with C++ types like classes? When I say type, obviously we already know that the primitive types of C++ directly map to primitive types of JNI. Like JInt is most likely just int, JDouble is most likely just double. Obviously this might change depending on the platform that you're running C++ on, but on most of the almost all of the modern platforms, 64-bit platforms, like JInt directly maps to int, JLine directly maps to line, JDouble directly maps to double, JFloat directly maps to float. And we've seen these in previous examples, right? So we interact with C++ through method or function calls. That's why, as I said before, JNI is an FFI, or foreign function interface. So foreign function interface. So it can only interact with foreign functions, or it can only call foreign functions. It cannot directly interact with C++ classes, for example. We need to create C++ objects on the heap and never on the stack, because when JNI is calling a function, basically when we use a native method in Java, it calls basically a foreign, or basically a native method or a native function in C++, right? And inside the body of the function, if we create an object on the stack, as soon as the control returns from C++ to Java, anything that is created on the stack in C++ gets destroyed. So if we want that object to be alive after we return from C++ to Java, we have to create it on the heap. So this is the first important step, right, that we need to understand. So, and once we create the object in that native function that the JNI calls, once we create that C++ object on the heap, now we have a pointer to that object. So even if the function call returns and we go out of that C++ function, the object can still be alive on the heap, on the native heap. And as long as we can have a pointer, which is a 64-bit integer address, right, we can access it and interact with that object. So When we create inside that C++ function, we create a C++ object and then send the address, which is the pointer, a 64-bit line or JLang of that C++ object to Java, right, as a JLang. And we've seen this before when we discussed our unsafe class, how we can write an unsafe class in Java. So C++ pointers are 64-bit. Obviously, I'm assuming a 64-bit platform. And JLang in C++ maps directly to lang, which is a 64-bit integer, signed integer. But for addresses, we don't really care about signed or unsigned because it's not really a number. We're not going to do math on them. And then we use static methods to handle allocation and freeing of C++ objects. Now, as you can see, not only we have to handle allocation, now we have to manually handle like freeing, because now it's on the heap. So when we're done with that C++ object in Java, we have to have some sort of mechanism so that we can manually delete that object on the native heap. So we have to have some sort of freeing native method in Java so that when we call it, it goes into a C++ functions and calls the delete on this pointer, on the pointer of this object that we have created on the heap, on the native heap. So private, obviously these should be static and we want them to be private native, and they should be native because they're supposed to directly interact with C++. So private, static, native, JLang, allocate. So allocate takes the parameters of the constructor of that C++ object, and those are mapped to basically these parameters that go inside this static allocate method in Java are the Java equivalent of the types that the constructor of the C++ needs, right? And then allocate returns a JLang, a 64-bit integer, which means it returns the pointer, the address of that C++ object that has been created on the native heap. So it must return an address. And then we create methods in Java class that mimic the member functions in C++. So a side note here, in Java, the terminology is that because everything is inside class, we call a function a method because methods are functions inside the class. We don't have a standalone function, right, in Java. Even a static method in Java, a static function is actually has to be inside a class. So in Java's terminology, a function is a method which means it belongs to a class. In C++, we can have a standalone functions that do not belong to any class. That's why the way we distinguish them from the methods that are inside classes in C++, we use the term member function. So when we say a function in C++, it means it's a standalone function. It doesn't belong to any class. But when we say it's a member function, it means it's actually a method, or it's a function that is a member of a class that belongs to a class. So there is a slight difference in the terminology. In Java, we say methods. In C++, we usually say member functions. So private native, so we create these methods that interact with and so we create a set of native methods that mimic the member function calls, and these are private natives, and the convention is we add a 0 at the end of the name of this method, and we've seen this when we looked at the handling like a standard input, output, how to write native methods to interact with them. And then we make the constructor private for the Java class that is equivalent to C++ class. Why? Because we want to force the user to directly call this allocate function, allocate method inside the Java class, so that the user is aware that we are actually allocating a C++ object. And because of that, then the user can guess that, okay, if I'm allocating, then there should be another method for freeing that class, right? Deleting the pointer, that C++ object. And yeah, so that when we make the constructor private and force the user to use this static allocate method to create an object, then it gives the user the clue that there should probably be a static method called free to be called when we're done with that Java class, right? Use public static members for allocate and free. So what do I mean by all of this? Let's look at an example. Let's say I have a % class in C++. Obviously, we have header files and CPP files, and that's the best practice. And I want to use this class, C++ class in Java. So the way I'm going to use it, I'm going to have a % class in Java, %.java, that mimics this person class in C++. So all the member function, it has all the functionalities. And then we don't really need the CPP file, so this could be from a library, and in a library we usually have the header file and the compiled binary, right, dynamically or statically. But here let's just assume I just wrote this myself, and I have access to both the header file and the CP file. Obviously the structure of the person.java must mimic what we have in the header file, right? Header file is the blueprint or the footprint of this class in C++. So only the header file is enough. So what do we do? So I have this header file for this person class. It has two private members. One is a std string name and int age. And then it has a few public members. First of all, it has a parameterized constructor. So it doesn't have a default constructor. It takes a std string name, and this is by value, not by reference. So when you pass a string here, it creates a local copy of it, and then assigns it. It's supposed to assign it to the name and then int age, right? And it assigns it to the age. And then it has a few methods. For example, it gets the name and returns the name, std string name by reference, right? Because we don't want to create an extra copy. And then int get age and void say hi. So we have two getters for name and age, and a method say hi that prints something on the console, right? So this is my class. Now I want to have a exact person.java in Java that has the exact same behavior. So what I do in Java, I create public class person, and obviously the interaction is happening through the JNI. So I have to have some sort of native library that implements the JNI calls. So I'm loading that native library. And then what do I need? So first of all, in Java, the only information that we need is have a pointer, an address to the object of this person class that has been created on the native heap, right? So we need to only have this information about the pointer or the address, which is a 64-bit long integer, right? So that's the only information we need. And then we need to have memory management, because in C++ we're going to create this person class on the heap. So we have to be able to allocate it private, static, native. So all these interactions with the C++ happen through native methods, right? Two native methods which are static for allocating and freeing, allocate 0, free 0. And then these are private. Later on we develop public methods that are exposed to the user. In allocate 0, I sending a Java string and a Java int, and we already know that the Java int maps directly to the C++ int, but a Java string doesn't map directly to the std string, so we have to do a little bit of extra work there in a C++ function. And then free 0, for free 0 we just and then allocate 0 returns a line, which is the pointer, the address of that object on the heap. And then free 0 just we sending the address of the object, the instance of the person class on the native that we want to delete, right? And then in C++, because it has the address, it just calls the delete on it. Obviously we can have other variants where we create an array of this person object, etc., right? But we just delegate it to the Java. So in Java we can have an array of these person classes. So okay, so these were the memory management. So we allocate and free. And then what else? We need to mimic the public member functions, right? std string get name. So private native string, this is Java string, get name 0. And we sending the pointer, the address, basically whatever, the only information that we need to communicate between Java and C++ in this case is the pointer or the address of that C++ object on the native heap, right? That's the only information. So this get name 0 sends the address of the specific object that we want to call the get name on, and then we later implement the JNI function for that. Get age 0, again the signature is the same. We send the pointer of the object that we want to call the get age on it, and this returns an int, which is age. Get name returns a Java string. Note that again in C++ it returns a std string, so we have to do a little bit of work to do the conversion manually when we go back from C++ to Java. And then say hi 0, again we're sending the address of the object, and then in C++ it calls the say hi method on the particular object that is at this address, right? So this is the native part of this implementation for this person class. So what is the Java part? So in the Java interfacing, this is the interface that the Java user actually interacts with. We make the constructor private, all right? So std Java string name int age, and again, the only information that we need to retain in Java is the pointer, the 64-bit address of the C++ object. And then we call this private static native allocate 0 and send a Java string and the Java int to C++. This is supposed to create a C++ person object and send us back a pointer. So that object has to be created on the native heap. It cannot be on the stack. It should be on the heap, right? Otherwise, when we return back from the JNI call, that object is going to die if it's not on the heap. All right, now these are the public interfaces that the user sees, or the Java user. One is the allocate. This is not a native, so this is public static person. Now, if you go back in the native implementation, the allocate returns the address, right? Now, obviously, we don't want the Java user to get an address. We want to Java user, when it calls the allocate and pass the parameters that are supposed to be in the constructor, we want the Java user to get actually a Java person object. And then all we do, we call the constructor, which is private, but we can still call it as long as we are within the scope of the person class. New person and name and age. All right. So what this does, it calls the constructor. In the constructor, the C++ object is created, and then this instance returns the pointer or the address of that particular C++ object. All right. So we are giving the user back a Java object of type person, and behind the scenes a C++ object of type person is created on the native heap, and then this instance of the person retains the address, the 64-bit address. And then we need to also have a public static void for free, and we say, and then it's a Java person object, and then because it's a static method, we say, okay, we call the free 0, which is native, and for this native, again, because it interacts with C++, the only information that it needs to send is the pointer, the 64-bit address of that particular instance, right? And any instance of the person that is created in Java has this pointer, knows the address of the C++ object that is equivalent to this. And obviously the other methods are very easy because we already have a native method for them. So for example, public string get name, we just call the get name 0 and send the address of the C++ object that is associated with this instance of this Java person, right? Get age 0, we send again the pointer, say hi 0, the pointer. This way we can have many Java objects of type person, and each one of them basically is associated with the C++ object of type person. We exactly mimic the behavior, all the public member functions of this person class in C++. Now, obviously, this can get very complicated. For example, if one of the arguments of the constructor or any of the member functions of the person class is actually another class in C++, then it gets complicated. But again, once we understand how this whole system works, it's very easy to add more levels of complexity to this implementation. So let's head to Eclipse and try to run a few examples. So in Eclipse, I created this test 34, and in test 34, I have this person .java. But before that, in my C++ code, in the header file, I created this person.h, right? This is the class that I start to write in C++. And I'm including the IO stream because I believe the std string is included in the IO stream. Or I could just include the string itself, that's fine. And what happens then, and then the implementation is inside the source src, which is a person.cpp. Let's see. I guess capital P. or I put it inside the header file, but that's fine. I put it inside the header folder, but person cpp. So in the person.cpp, the constructor takes a std string name by value and then age, and then uses the initializer list, so initialization, and assigns them directly to the name and age. Obviously, I'm including the person.h, the header file, and it also prints some message to the console. Person class created, name was this, and age was this, right? So this prints a message to the console so that we are sure that a person class, a person object was created in C++. And then the destructor, when we have constructor, we have destructor, and the destructor by default we make it a virtual. Here we're not doing any inheritance, but if another class is inheriting from this class person, the destructor should be virtual, just for safety. And then in the destructor, we do the same thing. We print something to the console. Person class destroyed, name was this, and age was this. And note that there is no resources. We're not acquiring any memory resources. Basically, the members are not pointers, so we don't need to call delete on any of the member functions, right? So std string, it automatically manages its own resources, so we don't need to do any extra work. And then get name returns the std string by reference. We just return the name. Get age, return the age, and say hi, and we print something to the console. Hi from person, name was this, and then age was this. These messages are just showing that we are actually interacting with the C++ object, which is the person. Now in Java, I do the same thing. In my person class in Java that is supposed to map to the person.h, or this class person in C++, has two parts. One is, obviously I need to load a dynamic library that is the bridge from Java to C++. The first part is private native parts that handle the communication with C++. And then the second part is the public part, which is interfacing the Java, right? Handling how the user of this class is going to interact with this person. And we make the constructor private, and then we have public static person allocate, public static void free, and a string get name, int get age, and void say hi. All right. And again, the only information that we need to retain in this Java class is a 64-bit pointer, the address of that person class in C++ that is generated on the native heap. So the next thing that we do is the routine. We select our person.java and then run the java-h tool, because we have a couple of native methods that must be implemented. And then it creates a test34_person header. So it has a method for allocate 0, which returns a J line, which is a 64-bit address, and it maps to C++ long on my platform. Free 0, it doesn't return anything, but it sends the address of the object. So we just have to call the delete on it. Get name 0, it returns a J string and sends the address of the object. Get age 0, it sends the address to C++, returns a JInt, and say hi 0, it sends the address and doesn't return anything. And these are very typical. We've seen it many times in previous lectures. So how do we do the implementation? I have this CPP file, CPP to Java class. So allocate 0. Obviously, as I mentioned, we have to allocate the C++ object on the heap, not on the class. And one of the arguments of the constructor is a primitive type, which is fine, but the other one is a J string. We have to convert it to the C++ string. So we ask JVM to get us a string UTF-chars, and we give it the pointer to this J string, and it returns an array of characters. And then we create a person pointer, so person pointer person new person, and we're sending the array of characters, and basically the std string automatically has a constructor that accepts a array of characters, so the implicit conversion happens. We don't need to do anything. And then the age, so jint maps directly to int, so no problem there. All right, so we create our person, C++ person on the native heap because we're using the new. And then note that this array of characters is a copy that the JVM creates on the Java heap, so we have to release it. And releasing it basically doesn't create a problem here, because again, this std string passed by value, not by reference. So these name characters creates a copy of std string and it's assigned here. So when we go out of this scope, this array of characters is destroyed, but the copy is still retained inside the person class that was created, so it's not destroyed. If we pass by reference, then there is a problem there. There could be a problem and we have to be careful. But here we pass by value, a copy of the std string is created inside the person object. These array of characters, we have to destroy them. We ask the JVM to release them. And then now we have a person pointer, which is a 64-bit integer. And we cannot directly send it to Java because it's not a person pointer, right? The JNI function expects a JLang. So we just directly convert it to a JLang, right? It doesn't matter. It doesn't change anything. It just changes the way the compiler interprets it, all right? So free, we're sending the address JLang pointer and we convert it to a person pointer so that the type conversion, now the compiler knows this is actually a person, so it has to, and then when we call the delete on this person pointer, now the compiler knows that it has to go to the heap at this address and delete this number of bytes, basically the size of the person. And when we call the delete, obviously the destructor is called, so we will see the message, this message that this person was destroyed in C++. Get name 0, and so all the methods are very easy to implement. We send the address, we convert the address to the actual person pointer, and then we call the method of the person pointer. So person, when get name 0, person get name, this returns a std string. We have to convert it to CS style string by calling the .cstr. But then we have to also ask JVM to create a new Java string because we have to return a J string, all right? And for get age is much simpler because the get age member function actually returns a int which is mapped to JInt, so we just directly call it. So we convert the JLang address to the person pointer and then we return the result of the calling get age on the person class. Say hi 0, it returns void, so the same story. So we convert the JLang address to the person pointer and then call the say hi on it. That's it. That's all we need to do. So all we have to do, basically, we compile this and then copy and paste the dynamic library. So binary dynamic library, we copy in the JNI, we paste it here. Yes. And then I go back to my test 34 here. I created another class called test person, right? In test 1, I'm creating one object. So I called this person. This person is the Java. Note that now we are all in Java and we don't need to load the dynamic library in this test person because I don't have a native method here. However, I am loading that dynamic library is in a person class itself. So as long as this class is loaded in the memory, all these JNI bridges are established through this dynamic library, so and we are good to go. So in test person, again, the constructor is private. So if someone wants to create a person object, they have to look at the public API and they see that there is an allocate method. And when there is an allocate, it gives a strong hint that there should be a free method also, right? So allocate, so we create an object of type person in Java using the allocate method, and we're sending a Java object that the constructor requires, which is a name and age. As soon as this is basically this allocation happens, we see that a new person class object is created in C++, and therefore the constructor of the person class is called. So we should see this message is printed. And then when we call the free, this object is destroyed in C++, and therefore we should see this message inside the destructor printed. All right, so let's just run the test 1. Yeah. So person class created, name Bob, age 21. This means that a person class in C++ was created, and we got the instance of this person in Java. And then person class destroyed, which means we successfully called the destructor on that. And now let's add this, Bob say hi. So we create this Bob class, Bob object, and hi from person named Bob age 21. So we successfully called this say hi of this person class in C++. And the interface is this person, basically this person object in Java. All right. Now we can also interact with the get age and get name. So let's run this. So we create the class, the object Bob, age 21. We call the say hi method on it, and then get age 21, get name Bob, and person class destroyed Bob age 21. All right. Now, obviously, we can create another person. We can, let's call it James, and James C++, age 35. All right. And then we say, let's say we call the say hi on the Bob, and then we call the get age on the Bob, and then James basically say hi, and then get name on the Bob, and then we do a sysout on the James dot get age, and then we free the James. So person dot free James and person free Bob. All right. Now, obviously, if the user forgets to call free, we have some memory leak. So as a safety measure, we should add the finalizer here and call the free method in it, the free 0. And then we should also add a extra flag so that we check if the memory has been freed for the instance of the person class or not. Okay. But here, for simplicity, I didn't add the finalizer. And the reason was that, first of all, we made the constructor private. So that gives a strong hint to the user that if the user needs to allocate, call the allocate to create a person object, then there's a high chance that also there's a free method that the user has to call. So making the constructor private and having a static public method for allocating is a very good indicator that there should be also a free method that the user has to call. All right, let's run this and see how this works. So person class created Bob 21, person class created James C++ age 35, and know that these are executed in C++, right? These are inside the constructor of the C++ class. And then say hi on the Bob, hi from person Bob, and then print the age of Bob 21, and then say hi from James, hi from person James C++, and sysout on the Bob get name Bob, James dot get age 35, and then person class destroyed James C++ age 35, and then person class destroyed Bob 21. So we are successfully creating an interface, a person class in Java that is basically an interface to a person class in C++.